Welcome to this RAD in Action webinar, Revolutionary UI Development with FireUI. I'm David I, and I'll be your host for this webinar. Here's a quick background about me. I'm the Vice President of Developer Relations and Chief Evangelist. My degree is in Computer Science from Cal Poly San Luis Obispo. Here's my email address and my Twitter handle and a short URL to my blog. Here's what we're going to cover today. We're going to start with a FireUI overview. And then I've broken up the presentation and demonstrations into 5 different parts: behavior services, multi-device designer, the T multi-view component, native and custom styles and controls, and multi-touch and multi-display. And we'll end with a live Q&A session. So let's get started looking at an overview of FireUI. FireUI is a collection of technologies new in Delphi, C++ Builder, and RAD Studio XE7 that allow you to create a shared user interface across all devices and form factors. It's made up of the UI form designer, multi-view components, behavior services, and the runtime library that's supported underneath. The multi-device designer allows you to create a master form design and then create specific views if needed for the different target platforms and devices. The master form uses stream inheritance to manage the differences between the device views and the master view. You have one project and one form across all devices. And again, there's shared UI code and event handling for the different targets. Delta streams are the real power behind FireUI. It's based on form inheritance streaming. It allows you to toggle visibility, position, change the size between views for each of the target devices. Device detection at runtime picks the best delta from the master view. You have one form object for all of the controls for all views, but then you can set the properties and event handler values for each of the target views that'll make up your application, whether it's a Windows app, an OS X app, an iOS app, an Android app, again, for different form factors and different devices within each target platform. The new T multi-view component is a super component. It's a drawer, it's a pop-up, and it's a panel all in one component. It's a container for other controls. The presentation at runtime is abstracted to a separate object, and you can set the presentation or let it be selected at runtime. So it's your choice. Do it in code, do it at design time. Let's start the first part and take a look at behavior services. Behavior services understands that every platform is different. Some of the work happens by the work you do in the IDE. A lot of the work happens behind the scenes. The API provides platform-appropriate design time and runtime behavior. It adds platform default to the size, position, and behavior for some controls. For example, in this bitmap, setting platform default for the tab control. Platform default behaviors are set at design time, but you can also modify them in your code. There's the new size property. It has a platform default that is enabled for these components and is automatically disabled when a component is resized. A tab position has a new platform default. It maps to the bottom for iOS and to the top for all other target platforms. You can set behavior services at design time by using the object inspector to set those property values, or they'll default when you first create your project. And again, many controls have size platform default equals true, but you can go in and change it. And as I mentioned, you can also change behavior services by setting property values at runtime in your code. So now let's take a look as Darren Kaczynski from our FireMonkey R&D team shows you demonstrations of using platform default behaviors and how the Delta streams work under the covers.
So this is just a FireMonkey form with a tab control, a few tab items, and a button. Let's look at the button. If we look at the object inspector, see we have this size property now, which is of type T control size. It has the height and width, and it has the platform default setting, and it's set to true. Now let's try adding a, let's add, say, an Android 5-inch phone view onto this. So a few things have happened here. Of course, you get the Android appearance, but if we look at the button, Let's come and look at the size again. You can see that the height and width have changed. Platform default is still set to true, but this is the standard size, the default size of a button for the Android platform. And if we do something, let's add a, say a 4-inch iPhone view. And now a few other things have changed here. The button, since there's no outline, it's a little harder to tell the size, but if we look here, we can see that it's also different from the master view, but it has platform default set to true. But another thing that's happened is you see that the tab items have moved to the bottom of the tab control. If we come back to the Android view, you see they're at the top. The iPhone view, they're at the bottom. And if we look at the tab control, see the tab position property, and you see that's set to platform default. Let me come back to the master view, and on the tab control, so you can still, of course, lock it to top or bottom position as you like, but if you set it to platform default, which is standard for a new tab control that you drop on a form, then it will automatically change the view based on the runtime platform or the view that's selected in the designer. Let me add another button here to the form. So this is a new control that was dropped, which of course means the platform default setting is true. But now let's resize it. Say this button, I want this button to be a large button for whatever reason. And if we look, you see that the platform default is now false, and the size is set to how we sized it in the designer. And if we come over to the Android view, you see it's also maintained that size, the size that we defined for it. And again, platform default is set to false. If we come back to the master view, and if this resizing was an accident, if, for example, we clicked on the corner and dragged when we didn't really mean to, we can come back here, set the size back to platform default, and it will resize the control to the default size. And if we look here on the Android view, you see that it's also been changed back to the default size. Now the platform default is set to true. So that's a look at some of the platform default behaviors that we've added. It lets you design a form and have the control size to what's appropriate for the runtime platform, and also to reposition the tab control, the tab items, based on the runtime platform. So here I have a project that has a FireUI form. I've defined a couple of views for it, an Android 5-inch phone and an Android 7-inch tablet. Let me add a few controls here. Let's add a couple buttons and an edit, say. So if we look at the form file here, this is a form file like what you would always expect to see. You have the form object, you have button object for the first button, the second button for the edit. If we go to the views, so the 5-inch, here we have the edit, the two buttons. Let's look at this form file. This is a lot different. There's only a few things listed here, but it's shown as inherited. And these are the differences between this view and the master view. The client height and client width have changed, and also the flag that it's the master view is also set to 0. Similarly, on the other one, Android 7, it's also an inherited view. Now let's say, for example, that button 2 does not apply for an Android 5-inch phone. For whatever reason, it activates functionality that does not exist on this form factor. Let's make this button 2 hidden in this form factor. Select button 2. make it invisible. Now if we view as text here, so we have inherited button 2 visible as false. This is the delta, the difference from the master form. This is very much like what you would expect to see with an inherited form. So how does the runtime know that these different views exist? Let's take a look at the code. You notice there's only one code tab for all of these views. The views are defined by this resource block. So you have this resource. This is for the master form resource. This loads, in this case, it would be unit1.fmx. This has existed since the beginning of FireMonkey. But then there's these two extra ones that have these funny names on them. These funny names are actually very specific names that are defined in the runtime. They're defined in this unit, system.android devices. There's a similar unit for iOS too, system.iOS devices. But you see we have all of these funny names defined. And these all correspond to different form factors. And not all of these are in use right now. We've reserved these names to handle new devices that may come out in the future. Different Android manufacturers come out with new devices. What we've done in this release is we've defined 6 of these. And these 6 correspond to what you see in the designer as the views that are available. Here we have 1, 2, 3, 4, 5, 6 different Android devices. So since the unit defines, in this case, these 2 delta streams, how does the runtime figure out which of these to load? Does it load all of them? Does it just load one of them? Well, let me show you that a little bit. When the form is created, one of the methods that's called is this new method called getDeltaStreams. This is defined on T common custom form. And what getDeltaStreams does is it calls a behavior service called getDisplayMetrics. And that returns information about the device that the application is being run on. And so it returns information about the physical screen size, the pixel density. And we take that information and we pass it to this runtime method, selectDevices, tDeviceInfo.selectDevices. What this method will do is it will return to us an ordered list of these 6 devices that we've defined. It rearranges them and puts them in order with the best match at the top and the worst match at the bottom. So when the form is loaded, we get this ordered list of the best matches of devices. In other words, the best matches of possible delta streams that may or may not exist. And then we send that ordered list to this method, readComponentDeltaResource. This is a runtime method. It's in system.classes. This looks for these resources. It takes that ordered list and it looks at these resources that have been linked into this unit, and it tries to find the best match. If you're running this form, this application, on an Android 5-inch phone, chances are that it's going to match this resource, which is the best resource to match the phone, and you'll get a screen that looks like this. If the device was, say, a 5.5 or a 6-inch phone, which one would it match? Well, it would depend on the screen density. It would depend on how it best matches, what the closest match is to which of these form factors. If you have a 6.5-inch phone, for example, it would probably match the 7-inch tablet more closely. A 5.5-inch phone would probably more closely match this one. That's how the runtime determines which of these delta views is going to be displayed. The delta views, the resources for the delta views are listed in the unit as resources. And then this mechanism, selectDevices, which is called by the form's getDeltaStreams method, determines the best match and tries to load the right resource at runtime. And that's how the delta stream mechanism works.
In part 2, we're going to go through the multi-device designer and how to create a master view and create customized views for each of the different devices and platforms. So the multi-device designer is new in EXE 7. You start with the master view when you create a new project, and then you can use the toolbar that's in the form designer to choose and customize any additional views that you might need for each platform and each device form factor. Again, stream inheritance only stores the differences between platform views and the master view. As I mentioned, there's only one form class for all platforms, and that the device-specific views are based on the streaming differences using stream inheritance, as you saw in Darren's demonstration of the deltas. There's one FMX file for the master and one FMX file per view that you create. And the compiler will selectively include only the current platform resources based on what target platform you set. So you'll see here down in the code, we've got the pound pragma resource and $R resource that identifies the master FMX file, and then the differences for changes you make in form and component properties in the subsequent target platform specific FMX files. You can also create your own custom views for additional device targets. This is how we also create the standard ones that are supported in the views in the pull-down menu of the form designer in the IDE. To create a custom view, you install a package with a unit that calls the tDeviceInfo add device method. This is used in the IDE to take advantage of the custom view. A custom view defines the device type, the physical screen pixels, the logical screen size, and aspect ratio. So let's see demonstrations by Jim McKeith on both the multi-device designer and how to create a custom view.
You'll notice right away under new, we just have VCL or multi-device. So there's no FireMonkey desktop versus FireMonkey mobile. You come in here, this is the wizard you can use to select. And so this applies to a multi-device app that will run on both desktop and mobile. So this bar here is the new multi-device designer view bar, and so we can change what style we're on. We're on the master view. We can change what style this is. So we say what it would look like on OS 10 versus iOS versus Android. So right off the bat, notice that the toolbar or the tab bar position or the tab control position changes when I go to iOS, and that's because the tab control tab position is set to platform default. So platform default means it adapts to whatever platform we've selected. That's the most common scenario you're going to run into the behavior services. You can also use it via code. So now let's look at the way the multi-device designer works. So if I come in here to the views, this gives me a list of all the potential views. Now these two are the custom views I added. The rest of these are stock views that come with EXE 7. Basically what you're going to do is you're going to design your UI, you're going to set your alignment, set your anchors, your padding, and your margins, etc. to get it laid out the way you want to. But then on some platforms, you're going to want to tweak it. So let's go ahead and say, let's design it for Android 4-inch phone. So we're going to say on Android 4-inch phone, we'll make this button bigger, for example, and we'll change the text on the button to say Android 4-inch. Now if I go back to the master view, it still has button 1, those changes didn't take effect. And that's because these changes are only applied to that specific view. So if I add a Android 7-inch tablet, and we'll go ahead and rotate this, we'll notice that, again, this doesn't have that change assigned to it. Now if I go to the code, we'll see here that it has the different devices here. So we have the two Android devices, the tablet and the phone. And if I say view as text, this is just going to show me the text for that particular view. Okay, so if I go back to view as form, and we'll go to the master and say view as text, we'll see now this has all of the controls on it. And that's because we use form stream inheritance to only store what's different between the different views. So let's say on my 7-inch tablet, I'm like, hey, I got a lot more real estate here. I want to add an additional button here. So we'll go ahead and add another button. One thing is this button got added to the master. So all components exist on the master. All right. So since it's on the master, that means it's also on our 4-inch phone. But we don't want a button on our 4-inch phone because we don't have enough screen real estate. So we come over here and we set the visibility to false. We can't delete it from here. Actually, we turn back visible. If I try and delete this, it says introduced an ancestor. That's because it's on the master view. So we can't delete it. We just set the visibility to false here. So it's still on our tablet, still on our master, but it's not on our 4-inch phone. Okay. If we want to make it visible again, we just simply select it from the list here, button 2, and set the visibility to true. So the thing about these views is you're going to probably do most of your designing at your master view and then only create these device-specific views when you want to tweak your view specifically for that. So since I've just created an Android 4-inch phone view, that view will automatically get used for the 3.5 and the 5-inch phone. It'll just use the regular stretching, anchors, and alignments like we saw previously to make it fit on those as well. Okay, so you don't have to define it for every one of these, but you can. And that's the really cool thing, is you do all the work on your master form, and then you can tweak it on all these other views if you need to, but only if you need to. You don't have to. Okay, so this is really the maximum of reuse and the maximum flexibility all in one. The one thing here is the events. So if I set an event handler here on this one, and we'll say show message button 1, and then we'll go to our 4-inch phone. We still have that same event handler, but we can change it. This is actually kind of cool, is I can come in here to the Object Inspector events, and I can delete that on-click event handler and make a new one here. Oops, I guess I want to give it a name. Call it Android Click, and say show message Android 4-inch. Okay, so now when we're on Android 4-inch, it's going to have a different behavior than it would on any other devices. So we go to Android 7, the button 1 has still the original button 1 click. Okay. Other thing is that we can have this revert back. So here we'll change the text to say Android 7-inch. All right, and I can right click on this and say revert to inherited, and it's going to revert back to inherited. Or I can just change, if I just change the text, let's do the text here again, text, change, I want to right click here and say revert to inherited, and that will change just that one property back. So you can change an entire control or just a property back. So that's the main things you need to know about the way the multi-device designer works. Very cool, very slick, great way to customize your view and take maximum advantage of your effort across as many devices as possible. This is going to really become a big deal, especially on tablets. So the tablet view versus the phone view versus the watch view versus the desktop view. So first thing, let's look at how we're going to create a custom view for FireUI. So what I have is a simple app here, and I'll show you the code here for the Pascal version. We get the design time width, which is just the form width and height, and display that, and that's going to be the logical size. And then we call our platform services to get the device metric service, to get the physical size. This is actual physical pixels on the screen, and the PPI. And then we're also going to call the device service to find out what class this device is. And so this is what the information that we need in order to create our own custom view. So here it is running on my Gear Live. So we see the physical dimensions are 320 by 320. So this is what is returned from the display metrics. And then the design is what we get here is the actual logical width and height that is used at design time. You see is 312 or 213 by 213, and the PPI is 240. So there's actually a formula you can use to calculate this all out. as well. But the class is tablet. The reason the class is tablet is because when XE7 was released, there were no Android Wear devices released yet. So there wasn't a way to test to see what the class should be, and so it just defaults to tablet. I suspect in a future update we'll see classes besides tablet and phone getting support as those devices show up. So right now it shows up as tablet. So one note about Android Wear is if you want to launch your app manually, you can just tap the screen and swipe up on here and come down to Start. And then you go to this menu here and you find your app you want to launch. For example, here it is, Hello FireUI, the one I just launched, and you tap it and it launches it. So that's how you can launch your app again if you've already installed it on your Android Wear device. So now once I have that information, then I'm going to create this right here, this class that defines this, okay? So the view name is the name of the view we're going to use. We're going to call it Gear Live. And we create, in the initialization section, we call add device. And here's their class, which is tablet, and our view name. And we specify the size is 320 by 320. So this is the physical size, and here's the logical size. And the platform is Android. And then here is the PPI, pixels per inch, and exclusive. So exclusive means that we don't want this view that we're creating to be used for another device. So let's say we only define a Gear Live view on our application, and then we run that application on a phone, an Android phone. If we don't specify true, then it's going to say, hey, I have a view defined for this watch, and you know, it's a little smaller than a phone, but I'll go ahead and adapt it anyway, and I'll go ahead and adapt it. You don't want that to happen. So you want, for specialized devices like watches, Android Wear devices, or maybe TV display devices like the Fire TV, etc., or Google Glass, you want to set exclusive to true, and that means that you're only going to use that view on that specific device. So this is where you define the view, and then in finalization we remove it. And so this way it gets removed when the unit gets removed from memory. So here's the XML that we're going to add to our XML document. And so I just put that in here so that you can find it easily. And so this is the file we want to modify. It's in our username, app roaming, Embarcadero, BDS 15 mobile devices XML. So we just come in here and we define the name. We need to match the name that we had there. 3 is for Android, form factor is for tablet, and then those are just the ordinal values of those enumerations, so you can look them up that way. And so we're only going to enable portrait mode because there's no rotation on a watch. Android Wear only has one orientation. And so this is the width and height of the display we're going to make there. So this needs to match what we had before in our Pascal file. So this is the logical size, the design size here, okay? And then this is where that is displayed on the artwork, okay? So the artwork, we're going to start at 227 pixels from the top and 313 from the left. No status bar, and then our artwork is a PNG file. So what I did is I went to Samsung and got one of their images for their watches and downloaded that for that. And then I resized it so that the size of the watch face fits 213 by 213. Okay? And then I just found the upper left corner of it and put that here. So once you've done that, you've defined your mobile device's XML file. If you come to Designer, we have it available here. So I can select Gear Live. You'll notice that when I go to the Moto 360, these circles are visible. And so the circles actually I added, and if we go back to the master view, you can see both of them. There's actually a blue and a red circle here, but they look purple because they're right together. The blue circle is slightly bigger than the red circle. And so what I'm doing here is the red circle is right on the line of what's visible. Now there's actually a little part at the bottom here that's cut off on the Moto 360 for the light sensors right there. So this just is so I can see what would be visible. And so this is actually a design surface here. I could put a component there, have something go off the edge, but it wouldn't be visible. So I have the red line just so I can see where that's going to go at, just for the purposes of designing on a round watch face. You don't want to have this visible on your watch at runtime. So anyway, there we go. I've defined both the Gear Live and the Moto 360. In order for your app that you design for one of these new views, to work with that view, you have to include the unit that defines the view. So this unit here defines the Gear Live view, this unit here defines the Moto 360 view. So that unit has to be included in your app that's deployed to the watch later. So later when you're making an app that's going to run the watch, so for example here this Hello FireUI includes those two files. Okay, so it has to include those in order for it to be able to select those views at runtime. So if it doesn't have the definition of this device, then it can't know to select that view. So hopefully that makes sense. So a trick I found is that if you create a component, so here I've created a component just called Android Wear Views, and this component, all it does is uses these two units. Okay, and then I have a property that just publishes, it says, hey, I support the Gear Live and the Moto 360. Probably a more elegant way to do that, but the main thing is all this component does is uses these two views. And so now I've installed that component because this package has to be installed in order for these views to show up in my list here. So for these views to show up in the list, two things are required. This package that defines the views has to be installed, and you have to add them to your mobile devices XML and then restart your IDE. Once you've done those two things, they'll show up in the list here. But then, since you're installing that package anyway, why not install this component? And then all you have to do is add that component to a app, and your app has access to those views. Okay? So if you don't have those, if you run your app and you say, hey, I want to design it for the Moto 360, and you run it and it uses the master view, you forgot to include the Gear Live device Pascal file in your app. Okay, so you have to include that, and the easy way to do that is to use a component.
In part 3, we'll take a look at the new Team Multiview component. Team Multiview component is really 4 presentations in one. Think of it as a super panel that can contain other controls, and that the presentation, the look and feel, depends on the device kind, tablet, smartphone, and so on, and the orientation of that device. Landscape, portrait mode. It automatically adapts to the different form factors, orientations for each of the platforms, and you can use code to create custom presentations as well. Team Multiview has several parts. It's got the master button that's part of your application, not always visible depending on the mode. For example, in portrait mode on some devices, you'll see that 3-line master button. In landscape mode, you might see a left-hand side selection panel and then the detail part of the form. Team Multiview can contain other controls that are visible in landscape and portrait mode. It's useful, for example, of having a slide-in menu or for navigating between master and detail views. And again, you'll always have the target control. It's usually a T-layout or tab control or some other control that contains the other components that are part of the user interface. This is really your main content area. Whether you're in a portrait mode or landscape mode on a smartphone or a tablet, a lot of that is done for you, but again, you can control it in your code as well. For Team Multiview, there's a platform default setting. You can also use popover mode where the menu will show up. You've got the drawer view where the button is covered when open, and then you can close it again. And then you can have the panel view where the button is always hidden, and it really looks like a master detail view project. And again, depending on the resolution, screen size, landscape, portrait on different devices, Team Multiview will do the right thing for your application. And you can also control in code for the different devices and the different orientations. At runtime, there's an open and close drawer. You say Multiview 1 hide master, Multiview show master. For a custom view, you'll need to implement a Team Multiview presentation, set it to custom presentation class. It also has a presenter and presenter state. That's a set of, is it installed? Is it opened? Is it moving? Is that presentation sliding in and sliding out in the drawer mode? Let's take a look at the new Team Multiview component in action with a demonstration by Serena DuPont.
So here's an application that I built for this demo. It's an HR Manager application, and this application uses the Multiview and also many different UI elements. And you can show and hide UI elements across the different views depending on your target form factor's screen real estate. So in this case here, what I've set my style to Windows on the master, and all the user interface styles across Windows and Mac have been extended to have the same user interface elements as their mobile counterpart. So for example here, you can set a bookmarks tool button, and it has the same styling that you would have then on, let's say, iOS, in the sense that when you switch this to your iOS application, you're going to get a styled bookmark button. And when you switch it to Windows, you get a style bookmark button. The glyph will look different, but you have the same style elements available. So you can build a universal user interface, so to speak, that has matching UI elements. The form and the master view is where you're going to be developing your application, designing the user interface for your application, but also be defining most of your application logic. When we go into each of the views, you can also define application logic on each of the views, but it's really good to design your UI and define your application logic as much as possible on the master view. So the created views here are the views that we've created and we selected from the available views, and these are predefined views. Available are the additional predefined views that you can select from or custom views that you have installed. So let's have a look here at our application. The multi-view component consists of a parented list view that's aligned to the client, and we also have a toolbar that's aligned to the top. And the multi-view component is a container, so to speak, so you can parent many different types of controls to it. However, it's really designed to be used for navigation, and so lists are a common element when building application navigation. What we have here is we have our multi-view component, and if we select our mode property, you can see that it's set to platform behavior. And what that means is that at runtime, it's automatically going to behave a certain predefined way that we have set. So for example, on an iPhone, it's going to display itself as a slide and drawer. So this company employees navigation on the left here, the list is going to be hidden by default and invoked via a swipe, for example. On an iPad, it's going to be shown as a docked panel in landscape mode, and then as a slide and drawer in portrait mode. So we have various predefined behaviors that are invoked at runtime via the platform behavior mode. If you wanted to overwrite that particular behavior for a specific view, you could just select the mode property and then toggle it to the view option that you want. So for example, the drawer option, a panel, or popover, or custom. Now for each of these options, we also have some settings that you can define. So for example, for the drawer, we have various drawer settings. We have the duration sliding, so how long is it going to slide for. The mode, overlap detail view, or we also have pushing detail view. So overlap means that when the drawer comes in, it's going to overlap and cover the content that you're seeing in your application, your detail view content. Pushing means it's going to push that content over to the side as the drawer slides in and it makes space for the drawer to show. Placement is the left or right placement of the drawer and how it's invoked, meaning you would swipe in from the right if it has placement on the right, and if you would swipe in from the left if it has placement on the left side. And the touch area size, and that's where you can define the touch target size as you like. Then we also have different properties for some of the other options, such as popover. You can again select appearance duration. So at what speed it comes up and how it appears when the popover is shown, the pop-up height, the height of that popover when it's shown. You can work with styles. You can also set the color, etc. And we also have our control size, and that's the height and width of our multi-view, and you can set that to the size you like. And we also have the split view option. So for example, whether or not the list, the multi-view component is shown on the right or left. So by default, it's on the left, but you can toggle that as you like. Now let's have a look at our toolbar here. And this toolbar has a label for the application title and two buttons. It has my refresh tool button here, and this is just this T-speed button aligned to the right that I've set to refresh tool button. And then we also have another speed button. It's our details tool button. And if I set that to visible here, you'll see this is the three-line icon that you usually see as another way of invoking the drawer menu. And many applications today that you likely are using on a frequent basis are using that paradigm as part of their user interface. So you can either swipe in the drawer or you can click on that icon to show the drawer navigation. And the way that that is defined here too is if we go to our multi-view component, we have a master button property, and that's set to speed button 2. and that is this button. And what that allows me to do is say, okay, I want to invoke the multi-view with its platform behavior that we've defined, both using the standard way via the platform behavior, such as being able to slide in a drawer on an iPhone in portrait mode, and also by clicking the master button. So let's have a look at some of the other views. So here we have an Android 5-inch view. So for example, here you will see that we're hiding some of the user interface that we have defined on the master. So here I have a separate list control, tablet HR list. And this is a list that I've named tablet HR list to make it easier for me to identify as I'm going between my views that is a section of UI elements that I want to hide on all form factors that aren't at least a tablet size. So for example, if I switch to my Android 5-inch view, you'll see here that I am not showing the tablet HR list. If I go to my Employees tab, tablet HR list, you'll see that it's set to invisible. So visible is set to false. And here, of course, you can also adjust like the height and width, for example, of your memos to fit for that particular form factor. So if I go to iPhone 4-inch here, I can adjust the height, for example, of my memo here. You could change the font. So for example, here I could go in to text settings for iPhone and set the font to blue if I wanted to. So you can fully customize the UI for each of your views as you like. If you go to iPad here, you'll see that I have that additional UI section and it's set to visible. So again, if I go to tablet HR list, that's my list box here, and I go to visible, you'll see that it's set to true because on a tablet form factor like my iPad, I've set that to true because I have a lot of additional screen real estate available. OS 10 is the same. I have a lot of screen real estate available, and I want to be able to show that section of my UI when the application is run on a desktop. So for example here, if you wanted to adjust the width and height of this particular button because you didn't want it to run so close to the bottom of the toolbar, you could go to the margins property here and you could set top and bottom properties. So you could fully customize those to adjust the presentation of your UI element. So you can see here I've made that control smaller by adjusting the bottom and top margins for that particular button. So if I switch now to Windows here, you see it has the same UI as my master form because on the master form I had set the style to Windows. And then of course if I go to an Android 10-inch tablet, again I have a lot more screen real estate. I'm going to want to show the tablet HR panel. And this is just done by toggling the visibility of this whole list box, and I just select it and I set my visibility to true or false. Now let's have a look at what this looks like at runtime. So for example, here I have my iPhone. I'm going to deploy this to iPhone on my simulator. So here you see the app running on my iPhone, and you can see here I have my master button, and I can show and hide the UI either by swiping it in or by using my master button. Now let's see what this looks like on an iPad. So here you see that in portrait mode, I have my button for invoking my menu, and I also can swipe it in if I didn't want to click on the details button. And if I now rotate my device, let's say rotate left, you can see that if I'm rotating my device, I now no longer see that button because I have my docked panel. And again, you could easily align this docked panel to the left or right.
In part 4, we're going to take a look at native and custom styles and controls. FireMonkey, since the beginning, has always supported custom styles. We've moved to using bitmap styles and providing built-in styles and premium styles for the different platforms that we support. So for iOS devices and Android devices, we support the native styles. For Windows and OS 10, we support the native styles. We also support custom styles. You can also use the style designer in the IDE to create, edit, and test FireMonkey styles. You can edit a default style or a custom style. And in the Style Designer in the IDE, you've got an object viewer for the different properties of each style type that you're pointing to. In this case, the text style for a label or the text of a button. You have the structure view, which shows you the layouts and the containers for all the different controls and parts of controls that are available in FireMonkey. And you also get a view of what that style settings look like at design time. We also provide an external bitmap style designer. The bitmap style designer is available from the tools menu in the IDE, and it allows you to create and modify bitmap styles. It's also an executable in the bin folder, and you can distribute the bitmap style designer with your applications. For example, you might have a customer that wants to create their own style, and then your code would load that style at runtime. Or if you're the programmer and you're not the graphic designer in your organization, you could give the bitmap style designer to a graphic designer. They'll do the graphic design work and give you back the style file that you can link into your application. The bitmap style designer allows you to create, edit, and test FireMonkey styles, create, edit, and test VCL styles. And if you see a VCL style that you like and you want to convert it into a FireMonkey style, you can load a VCL style and save it as a FireMonkey style. We also recently released a premium style and the standard styles for Android L or Android 5 Lollipop, the dark style, the dark blue style, and the light style. Here's some information about how to use that new Android 5 style in your Android target applications. There's the download link, and Serena DuPont has also blogged for how to grab the style if you're a RAD Studio customer, Delphi C++, or App Method customer. Also in EXE 7, we've extended the native iOS control support. In previous releases, FireMonkey had native look for the custom picker that was using the combo box, and the date picker that was using the calendar control. And we've enhanced in EXE 7 to have the T-Edit family of controls also be mapped directly to the native iOS controls. Same control, different presentation, same properties, and so on. Uses the model view architecture underneath, and it gives you the best of both worlds, high performance and platform independent code for those T-Edit family of controls. And we'll also be extending our support for native controls in the future. So now what we're going to look at is demonstration of custom styles, also iPhone 6 and 6 Plus style support with Serena DuPont, and Darren Kaczynski is going to show you native iOS control support for the T-Edit family of controls.
You can also work with custom styles. So I'm going to go back to the master view here and select Stylebook. And when working with styles, you're going to want to load the appropriate custom style when you're working with custom styles for each of your views. So when working with the master view, place your stylebook onto the master, and then select a premium style that matches the style setting you've set here. So in this case, I've set it to Windows. So I'm going to load a premium Windows style. So for example, my Emerald Dark style. Click Apply and Close, and then on your form, you're going to want to go to the stylebook setting and set it to stylebook. This will apply the custom style to your Windows view here. And so now if I go to my Android view, I'm going to want to load my Android style. The premium Android style has different resolutions built right into it. So it has graphics for 1x, 1.5x, 2x, and 3x resolutions built right in. So for example, here I'm going to select the FMX Android style, and I'm going to select the Coral Crystal style. As you can see here, this is one of our other custom styles, and that I've now applied to my Android view. And if I go to iPad, I'm going to want to select my iPad style. And I'm just going to go through some of the different styles that we have available as part of our premium style pack. So for example, I'm going to select the iOS Sterling style. It's a nice light style. If I go to iPhone, I'm going to select a different custom style. So going back to my Android style, my stylebook here, and I'm going to select the iOS Emerald Dark style. And then you can go to, let's say, OS 10. For OS 10, you're going to want to load the OS 10 style. Such as the Emerald Crystal style. So you can see that you can easily customize the application UI using premium styles as well. Now you can also, of course, customize the UI for each of the views when working with the custom styles. For example, here I could say I want to move the button over to the right some more, and I could easily just adjust the margins to change the position of that particular control. I'm going to select a blank form. And then we have here our master view, and you can see from the drop down, you see all the available views. And a range of iPhone devices. We have a 3.5 inch and a 4 inch, and then a 4.7 and 5.5, and an iPad. 4.7 inch is the new iPhone 6, and the iPhone 5.5 inch is the new iPhone 6 Plus. Okay, so let's start out by putting a toolbar onto a form here and a label. And I'm going to align the label to content. And I'm going to center it. It's really important when you're developing an application for multiple platforms to go ahead and use anchors, alignment, margins, etc. And we have a text settings property here. We can select the horizontal alignment, so for example, center. And then we also have a font property. So the style across Windows, iOS, Android, and Mac, each style has predefined properties for the height and width of each element. So for example, here we have predefined settings for the label font. If you wanted to override any of those, you just select the control on the master here and select styled settings. And then you could override, for example, the size or the font color. And if you uncheck those, you're then able to select those properties within text settings. So for example, here I unchecked font color, and I can change that now to blue, for example. Or font size, and you can then go in and set that to a larger font. You can switch here between, of course, OS X, iOS, and Android. So I'm going to check that again, and I'm going to go back to the kind of standard settings for a toolbar label. Now, the best process for laying out your application on the master is to, of course, use alignment and anchors. So for example, here I have a toolbar with a parented label. And let's say I want to also display a button. So I'm going to use the speed button. And I'm going to select the alignment of left. And I'm going to change the style here to a glyph button. So for example, the action tool button. This is the design of the control if you wanted to, for example, invoke the share sheet or the sharing functionality across Android or iOS, you would use this icon. And now what I'm going to do is I'm also going to set a margin on the left side of, let's say, 2, and maybe 1 at the top and 1 at the bottom. And that matters more depending on the controls. So for some of the controls, if they're transparent and you're just seeing the glyph and you don't have a selected highlight color, it's really not that relevant. But if you have a button style, like a traditional button style, I'll show you an example here, you're going to want to set a margin for the top and bottom. So for example, if we have a look at the button style here, you're going to want to set the margin for top and bottom so that the button doesn't actually run into the edges of the toolbar. So I'm going to go back here and select a glyph. And I'm going to change the name of my toolbar label, the application title, to application title. Okay, so now I want to create some views. So I'm going to create a view for iPhone 4.7 inch. And I'm going to create a view for Android 4 inch. Now, if you're looking to customize the user interface for just a platform rather than the specific form factor or device, then you only need to create one platform-specific view. So what that means is if I wanted to target iOS and Android, but I wasn't too concerned about specific layout changes for each of the different form factors, and I wanted to just add platform-specific behavior, for example, display a different message to an Android user than I want an iOS user, then you just need to create one iOS view and one Android view. Of course, if you want to fully customize the look and feel of that particular view in the application, you're going to want to create a device-specific view. So here I have my iOS iPhone 4.7 inch view, and then I also have my iPhone 5.5 inch view. Now, the styling that you see here is a native built-in style. So for iPhone 5.5, we have a 3x style built in. So iPhone 5.5 inch, which is the iPhone 6 Plus, is a high-resolution device. higher resolution than the 4.7-inch iPhone 6, and we have built-in support for 3x styling, and that's also true for custom styles as well. So if you were to load a style via a stylebook, you would put a stylebook onto your form. Again, when you're working with custom styles, you want to, on the master, load the custom style that's related to the stylebook, the style option that you've set here. So in this case, I've set Android. You're going to go to the stylebook and select your premium style. So for example, Coral Crystal, apply and close. And then on the form, you have to go and select the stylebook, and it will apply the style. Now you go down to, for example, iPhone 4.7-inch. Again, you double click on the style and you load your iOS specific style. Apply and close. And then you want to go through and do the same for all the different views. So for example, if I'm running this application or deploying this application on an iPhone 6 Plus, it will show the iPhone 6 Plus style. If I deploy it to an iPhone 6, it will show the iPhone 6 version of the style, which is a 2x resolution. So let's have another look at a demo here that I have. It's a good example of designing an application for multiple platforms. So for example, here I'm using the multi-view control, and this is a control that allows you to fully customize user interface, and it can be rendered as either a slide and drawer, a pop-over menu, a dock panel, etc. And in this case, what I have here is I have my multi-view, and I have a toolbar here at the top, and I have a list view that's bound to some sample data. And now, as you can see, if I go, for example, to iPhone 4-inch, what's going to happen is at runtime, this will be displayed as my slide and drawer. So I can go ahead at design time here and disable the visibility of the multi-view component. And you can see this is what's going to be shown unless the user slides in the drawer, for example. I'm going to fine-tune this, and I'm actually going to change the font to a smaller font so that it fits more properly, and I'm actually going to move this over a little bit. So this allows you then to fully customize the position of the controls and the layout for that particular form factor. And so you're going to be able to swipe in, make your user selection, and then bring up the employee profile as you can see in the sample application. Here I have a lot more room because it's a Windows application, but on my iPhone view, I don't have room in some cases to display a lot of text. So what you could do is if you wanted to hide the notes in your iPhone application, you would just go and select Memo 1 and then set the visibility to false. And so then at runtime on an iPhone 4 device, iPhone 4-inch device, it's not going to show that memo. That also allows you to customize the user interface, for example, for a tablet. So for example, if you had a lot more text here or you had additional user interface elements on this form, you could then select them for your iPad or your Android tablet device, and you could go ahead and customize the layout. You could show more user interface controls, have a T-image, for example, on here. You could allow the user to attach files, etc. for this particular employee in this demo application. And you're able to fully leverage the layout and form factor of a tablet. And of course, on your iPhone or Android device, you would go ahead and select that control and then set the visibility to false so that it's not shown on that particular form factor. And that's a good example of being able to fully customize the user interface according to the form factor. And now I'm going to also show you a quick demo here of a master detail template application. And the master detail template application is part of the new multi-device application wizard. So for example, I'll show you here at design time. If I'm running this app on an iPhone 6 Plus, 5.5-inch device, you're going to see at runtime, you're going to see it as a docked panel. The employee list displayed as a docked panel when it's in landscape mode, and in portrait mode, it's going to display this is a slide and drawer. So what you're going to see is you're going to see the main UI, which is the employee's profile, unless you swipe in and invoke the drawer. And on a 4.7-inch device, since it's a smaller form factor, you're going to see the drawer whether it's in portrait mode or in landscape mode. And I'm going to show you what this looks like at runtime here on an iPhone 6 device in both portrait and landscape mode.
So here we have a form that has an edit control. If we look at the object inspector, you see that there's this new property, control type. By default, it's set to styled. We can change it to be a platform control type. And you see in the designer, the control has changed to outline. This lets you design your form around it. You can set the size of it, but we only show the outline to indicate that this is going to use a native presentation. If we look at the edit control itself, we see that tCustomEdit now descends from this new type, tPresented tPresented control is declared in this unit fmx controls.presentation. And you see tPresented control descends from tStyled control, and this is where the control type enumeration is declared. And you can see this is also where the model field exists. And we also have this field called presentation proxy. The presentation proxy is an object that handles the communication between the FireMonkey control and the presentation, whether it's the styled presentation or the native presentation. That proxy class is declared here. This is the tPresentation proxy. If we look at the data model itself, there's this unit fmx controls.model, and this defines the base tData model class. There's not a whole lot to this. For the edit control, there's a custom subclass of this, which is declared in fmx edit. This is the tCustomEdit model. It descends from tData model. And this defines essentially the properties that the model stores. This is the data model for the edit control. And what happens is the model can send messages to the presentation. And these constants define message IDs. So you have things like the selection start change, the selection length changed, whether it's read only, if it's a password. These are the messages that the model can send to the presentation. And if we look at the actual native implementation of the tEdit, we have this unit tiOS native edit. And you see this does use a UI text field on iOS. You see that this mostly consists of message handling methods. So these are message handlers for the messages that we saw in the fmx edit. So that shows you a little bit about how this new architecture works. And it's implemented on the tEdit control for RAD Studio XE7. And the native presentation is provided for iOS, also in XE7. In the future, we would like to expand this to include more controls and more platforms.
Finally, in part 5, we're going to look at XE7 support for multi-touch and multi-monitor support. New in XE7 is a multi-touch unit called the tMulti-Touch Manager. We have 3 ways to do touch support across the platforms. On gesture, using the tGesture Manager has been around for several releases now. New in XE7 are the events on tap and on touch to add to the on gesture event handler. Now you need to decide in advance when you start building your project whether you want to use one of these multi-touch technologies. On gesture gives you the built-in standard and interactive gestures. On tap allows you to tap on the screen and it'll give you the coordinates, a single point for where you've tapped. On touch lets you touch one or more fingers on the surface of your application. So on tap is a single tap on a UI component, including a form. On touch allows you to use multi-touch gestures that are truly gestures in your application. The T-touch action takes place that tells you what kind of action happened when the touch occurred. Touch down, you lift your finger off, you're moving your finger, then there's none, or you've canceled a gesture. Here's what the code might look like in C++ and Object Pascal. You'll get an array of touches. You get the XY location for each of the touch points that happen. And then you'll have the touch action. And we've also added multi-monitor in XE7 for FireMonkey. Multi-monitor support was already available in VCL for several releases. In VCL, it's the T-screen object, and in FMX, it's also the T-screen object. You get the monitor count in VCL, display count in FMX. And then within the count of displays that you have in your screen, you can look at the index or the monitor number, the top left, width, and height. And in FMX, you also get a true and false Boolean for which is the primary screen in the array of displays. So let's take a look at multi-touch and multi-monitor in action. Here's a quick sample of an Object Pascal and C++ FireMonkey multi-touch application. We've got a form here. And on the form, we've hooked the onTouch event. And if the touch action is down, then we'll get the number of touches by the length of the array of touch points. And then if the action is the down action, then we'll display the number of touches and the X and Y location where the touch took place for each touch. Same thing for C++. Look at form touch. If the action is a touch down, then get the number of touches and display for each touch the XY location of the touch. So first, let's run this application on Android, and we'll hit run, and then I'll switch over to my display, and I've got the application running here. So as I touch one finger down, two fingers down, 3, 4, 9, 10. See if I can get to 10. Sometimes I can, sometimes I can't. And then go and activate my iOS device with my iPhone 4, and we'll run the application. And over here on my Macintosh using Reflector, I can see my application. I can put some fingers down, 1, 2, there's 4. And then if I didn't want to use multi-touch, I wanted to use just tap, I could just double-click and do on tap and turn off the other handler. What I get there is a point where the on tap takes place. And again, you have to decide to use on tap, use on touch, or on gesture. It's your choice as you begin your project. And make sure you hook one of the appropriate event handlers. I'm in the RAD Studio XE7 IDE, and I've got a project group loaded with a VCL and an FireMonkey multi-monitor, just simple demonstration application. On my Windows machine, if we go to the control panel, display, and look at the orientation, we've got two monitors, the built-in monitor on my Mac and an external monitor as well. If we look at the VCL application on the button event handler, we're going to get the monitor count for the screen, and then we're going to iterate through the screen count and display the monitor number for each one. We're going to use bool to stir to take the Boolean primary field of the monitor item and display true or false. And then we'll get the top left width and height of each of the monitors. Over on the FireMonkey side, we'll do a similar thing. We'll use the display count, we'll iterate through it, and we'll populate the memo with the display numbers, and then display using bool to stir which of the displays is the primary display. And then we'll get the bounds top left width and height of each of the displays. Then we can also extend our application to create forms and have them display on different displays. So let's go and run the VCL application first. And here's display screens. It found two. The first monitor is the primary monitor. It goes from 00 to 1440 by 900. And the second monitor, it's not the primary monitor, and it starts at top left 1440, and it's of width and height 1280 by 1024. Looking at the FireMonkey example and running it. Again, we'll display the screens. It finds two. The first monitor is the primary monitor, so it's set true, goes from 00 to 1440-900, and the second monitor, not the primary monitor, goes from 1440 to width and height 1280 by 1024. The same code for FireMonkey also works on the Macintosh if you build for Macintosh and run it with a multi-screen layout. So that's how easy it is to find out how many monitors you have, and then you can create forms and display them on different monitors. So in summary, FireUI allows you to build one UI, one user experience for all the different form factors and platforms. The multi-device designer allows you to create custom and unique user interfaces and user experiences for each of the specific devices that you choose to support across the 4 different platforms: Windows, OS X, iOS, and Android. And the new T-Multi-View component allows your application to adapt to each device form factor and orientation. There's lots of information available for the new FireUI technology in XE7. I've got some of the links here, and I'll also put these on my blog. There's DocWiki entries for the form designer, for working with FireMonkey styles, for the new T-Multi-View component, including tutorial, for multi-touch support inside of XE7, including gestures, on touch, and on tap. And there's also information about multi-monitor support that's new in FireMonkey and XE7. We also have session replays in the recent Codebase 9 about FireUI, the multi-device designer, T-Multi-View, touch management across different platforms, and what's new in FireMonkey in addition to FireUI. For more information, we also have the developer skill sprints. There's the landing page that's an ongoing series every Tuesday of short tips and tricks and techniques. And there's a playlist for all of the developer skill sprints that have taken place. I just want to remind you of special offers and bonus packs that are available this quarter for purchases and upgrades of our product. Enterprise purchases or upgrades from Pro to Enterprise order between January 21st and March 31st of this year, you'll receive a 10-user deployment license for the Enterprise mobility services. For those of you that are on XE2 and earlier that aren't eligible for regular upgrade pricing, you can upgrade from any previous version and get the upgrade price to XE7 when you purchase the upgrade with 1 year of support and maintenance. And that's for purchases from January 12th to March 31st. All of you who have XE7 or upgrade to XE7 get access to the free bonus pack, which includes the Object Pascal Handbook by Marco Cantu, Castalia for Delphi, the VCL and FireMonkey Premium Styles, and the Meta Converter Basic Edition, which will convert VCL applications to FireMonkey applications. And you can find all the details and requirements at the RAD offer page, www.embarcadero.com/RAD offer. And now it's time for Q&A. Ian was noting that the platform default and size affected, how is it related to the size of the device, the resolution, and so on. And Darren covered that, and we covered that as well, that the size is related to the target platform views that you're choosing, and ultimately under the covers, when things are rendered, it's the size of the and resolution of the different devices that you're going to run your application on. And as Darren mentioned, it uses its best effort to try to match the size of the device to the size of those views. And I also remind everybody that when you build for a platform, only the form stream parts for that platform are included in your application. So if you create an iOS view, but you're building for Android, you're only going to get the Android views linked in, those parts of the form stream that's related. So it's not, you're not going to get all of the different views of all the different platforms and devices. You'll only get it for that specific platform that you build for.
So Peter is going to send me an email. We had after I tried to answer some of his questions, he has an LG phone that apparently is displaying the wrong size. So it sounds like it's probably an issue with the LG phone. Might be a different screen density than we're expecting in IDE. So he's going to send me this information. Probably end up having to create a custom view for him that matches the LG's screen density and screen resolution. I first thought he was talking about the LG G Watch because I'm not a morning person. But anyway, he's going to email me. We'll get it taken care of. But it probably is going to be a screen density issue.
Yeah, and he mentioned it was the LG D320. I mean, there's so many different phones with different form factors and resolutions. And again, Darren's guidance that will try to match it. But creating a custom view, as Jim showed you how to create custom views, and there's documentation as well in the doc wiki and in the help file, will go a long way to creating a view that works for that phone. And then you know, the great thing is if people have other phones, follow Jim's instructions in the documentation, create a view, and then blog about it, put it up somewhere so everybody else can have that custom view and add it, because they might want to build apps to target those phones. We don't have every phone on the planet Earth here in the R&D group and in our offices, and we all have different phones, just to make sure that we can test on them as well.
Sometimes I think they're releasing new phones faster than we could probably create custom views for them.
And Marcus had a good point of having Peter read out the physical and logical resolution by using the platform services, which you showed example code of calling the platform services and displaying it for one of the what was it, Android Gear or one of the watches, I think.
Yeah, for the watches. Yep.
Yeah.
Exactly. And that same code will work across other devices, and I've had people use it on other devices, and it's like, oh, look, it's a entirely different DPI than we expect it to be.
Yep. And then I was going back and forth with Paul about the bitmap style designer. What he was saying was I was referring to the premium styles that we ship. What he was saying is that the default styles for iOS doesn't have a 3x graphic, so I need to check to see whether that was updated in update 1 or whether part of the premium styles also includes a 3x standard style for iOS. So I'll double check by loading the bitmap style designer and seeing if I see the 3x PNG. When I had asked in R&D, they said, oh yeah, the bitmap style designer can handle 3x PNG. Maybe we just didn't deliver an updated standard iOS style, the default style with 3x graphics. I thought we did, but again, I'll double check it and make sure that Serena or someone blogs and we put up the standard style file somewhere. But I know the style designer supports multiple resolutions. It does that regardless. It doesn't know that it's an Android style necessarily, and it handles all those up to 4x resolutions. So go ahead, Jim.
So Marcus just suggested that we set up a official EMBT Embarcadero collection for custom views, which is actually a good idea. I actually have the FireMonkey, the FMX views that I'm using for the I put up the watches on there, and if people want to post pull requests, I'd be happy to include other views on there if you want to create other views for other devices.
Yeah, I'll add I think you did a blog post and probably the link, what was it, to GitHub? I forget. I'll find that resource again for the samples that you have, and I'll put that as links in my blog. But you can also go to Jim's blog, delphi.org.
The multi-view component, I'm a big fan of that one. I use it quite a bit, and it's a lot of fun to work with. And it's one of those things, get it, start playing with it, experiment on different devices, and you'll see how it works pretty quickly. And there's an example of a custom view that's also ships in there as well that you can find in one of our demos that shows you how to create a custom view. So it's all really cool, fairly well put together, in my opinion. And then, like I said, the code is available in the sample that shows how to create a custom view as well. Yep. So take a look at that.
And I have the custom view link is on my blog. It was in the resource link. So
yeah, the thing that I wanted to add is that it might not be obvious for people that have been following our progress with FireMonkey on mobile, but the FireUI technology, the multi-device designer, is really unparalleled in the industry. There is nothing even getting close to it today. You can go for the various JavaScript-based tools, other native compilers, other languages, other development environments. There's really nothing it's not identical. It doesn't even get 50% close to what Delphi and C++ Builder and UpMethod provide in terms of the ability to create a visual representation of multiple devices and work with them visually and then hook your data and create really great mobile application from multiple devices with a single source. That's really a very significant differentiator of this product compared to other products out there.
Let's see, Eric was asking about platform default, and can that just control the height only? And platform default is both height and width. You can always choose other alignment things to make the contents fit inside containers, for example, like the text within the container and so on. Do you know of any other auto sizing, Jim? For example, if the label of a button or the text in a button is too large for the platform size?
I think then you'd end up having to size it manually, I believe.
Yep. Yeah, I don't remember an auto fit property. But yeah, if you're using the default size of the platform, make your font smaller. You can set the font as by the text settings. You could turn off font and then set a font so you can have smaller fonts if you have to put a lot of text in a small button, for example. Better would be to sometimes use style and bitmaps for certain common operations like the share sheet thing in the camera versus putting text about take a picture. Just put a camera icon in there, for example. I think it was Steve was asking or commenting about the metrics. He has two different 7-inch Android tablets that have two different resolutions and densities. And Jim, and you can double check on this, the fit is not the screen size. We use like the naming conventions to say things like screen size, but it really is the resolution and density, right?
Yeah, the resolution and density is really what it comes down to. They're actually all three of them come into play, but the screen size, the physical number of inches, and the resolution is what you use to calculate the density. So, but the density and the resolution are probably the most important part of that.
And that's what Darren pointed to when he was going down inside the code about how some of this works for the different device views. And also you covered it, Jim, when you were building a custom view. You were also in that same world of density and resolution, right?
Right. So if you're getting some weird things don't seem to be matching up the way you expect them to, that code I showed where I get the dots per inch and the physical resolution versus logical resolution, get that code, run it on your target device, and look at it and see what that is. And then you can actually look into the code Darren pointed you to that shows you where all of the built-in devices are defined and see if it matches up, what it matches up to, and what it lands in the range between, because what's probably happening is you're getting a different one matching up, and so it's behaving not the way you expect it to.
And if you have the Pro and above editions, you have the source code. You could add the source code to your project. You could put a breakpoint in that source code to see what FireMonkey's doing under the covers, which of those 6 it's choosing to set a breakpoint, and right, and see where it's through that list where it's choosing the best fit. Dante was asking about portrait and landscape and form factor, and for me, I use Project Options application orientation, where you can choose custom orientation and restrict or select the orientations you want your app to support. There was also a question, I don't know if it was Steve again, about working with different forms. He wanted to have custom forms for different orientations and different size forms. That's the sort of old school way. You can choose to use the multi-view, but you don't have to. You can have multiple forms, and you can, in the project startup code before application run, you can test, again, the resolution, client height and width, for example, and choose which form you want to use. That's always the case. You can do that. You'll still need a main form very quickly, but you can add code and look and decide. In the other case, there was another question about, can you tell which orientation you're on, or if the orientation changes by the user, and do the right thing, and just hook the on resize for the form. So it'll get an on resize event when you're in portrait or landscape. There may be an iOS or Android API for getting the orientation itself. I'm not sure. I've always just used on resize for the form.
Oh, I think that's what I've done too, is on resize. I'm trying to think if there's something different there. Let me look real quick. I think that's probably the way to do it, is on resize.
There's no event for on landscape or on portrait. I know that for a fact. So
right, yeah. So I think, well, I know what I've done, and I think I've seen other people do, is to use on resize event, and you just look at the aspect ratio. Is it wider than it is tall, or taller than it is wide? If it's taller than it's wide, then your portrait. If it's wider than it's tall, your landscape.
or if you have a square, anyway, square tablet, there's no such thing. Well, maybe there is. Maybe somebody has a square tablet.
Well, most of the watches are square, close to square, but they don't have a rotation. They're always in the same orientation there.
There was a question about what about handling multiple spoken languages or the strings in your applications, and I pointed to Sisualizer, Sisulizer, and Steve also mentioned TSILANG, a TSI Lang component, as another that has a dictionary and to support multi-language user interfaces for spoken languages, written languages.
Yeah, and you can use the same, if you really wanted to, if you wanted to have completely separate UIs for different languages, you could use the same technique as we talked about for changing between landscape and portrait, except instead of detecting the resolution, you would detect the language and then display the form based on which language they're using. And
then Andrew was asking about the premium styles for XE7, and you put a link in, and I put my general link is always cc4codecentral.embarcadero.com/myreg. But you can also go to the community menu and do my user download or my registered user download and get to that place. You need to log in so that we can validate that you have the rights to XE7 and which version, which edition of XE7, whether it's Delphi, RAD Studio, and so on. And that's where you'll find the ebook. That's where you'll find the Media Converter Basic Edition. That's where you'll find the premium styles. Andrew's asking about videos for handling advertising and freemium, and Jim, you put in-app purchase video links, YouTube video links in the Q&A log,
yep.
So people can...
From our skill sprint, we have the in-app purchase skill sprint, which I linked to, and then the one for in-app advertising,
yep,
which I linked to as well.
And can FMX handle other images besides bitmaps? And my answer is yes. JPEG, PNG.
Yep, JPEG and PNG for sure. I saw someone was doing something with SVGs. If you kind of have to do a little tweaking with it, but you can get SVG, which is the scalable vector graphics, which are XML-based graphics, which are kind of cool. But some people doing stuff with that too as well. So yeah, there's lots of image format for more support.
Can you drive the form size with any custom bitmap? And if so, is there limit max resolution? I don't know any max resolution.
I saw someone was doing some blog posts about doing 4K screen support from a FireMonkey application, and that's 4K screen. That's as big as it gets, right? I guess they do have 8K screens now, but yeah, you can. I don't know if there's a max resolution on what you can deal with. You obviously could run out of memory issues, I guess, at some point though.
Jim, have a good evening.
Great, thanks. Talk to you tomorrow, dude.
Okay, everyone. Bye.